the past couple weeks, we've been working on some of the basic concepts of probability. Today, we're going to be working on how to find the probability when we're given data in a table. And so we're just working on how to pull the information from our table to find different answers to probability problems. Okay, so I found some interesting information relating different age groups to if they use different types of social media platforms. I thought that was some interesting information. And so all of the problems that we're going to be answering will actually be based on this data, okay? And so before we actually start with the problems or the question part of the lesson, I want to make sure that you understand how to read the table, okay? And so this table, it says it's comparing the social media platform usage with their age. And so what the numbers in this table represent are how many people that were studied or surveyed responded yes in each category when asked if they use the following social media platforms. So like if we kind of start reading this table, this 51 would be the number of people or the number of, I guess, 13 to 17-year-olds that said they use Facebook as one of their social media platforms. Okay. There's 72 13 to 17-year-olds that use Instagram, so on and so forth. There's 35 of the people in this survey. So remember, they only surveyed, a select group, but there's 35 people that are in the 30 to 49 age group that use Pinterest. And so hopefully that kind of helps you to read it. If you look at the totals, and remember, because you would have learned this in other classes, if they do not give you the totals, all you have to do, like if I didn't know how many people were in the 13 to 17 age group, I would just add up all these numbers because that's how many people there are that are in that age group. And then if you add them up, you'll get 309. So if they don't give you the totals, just add them. And same thing, like if I was wanting to know how many total people in this survey said that they do use Snapchat, I would just add up all the ones that are in the Snapchat row, okay? And if I did, you'd get 168, okay? So that's how to read the table. So now we're going to start practicing how to answer questions using this data in terms of probability. All right. So we're just going to work through the problems, and I'm going to show you how to pull your information. Please make sure that if you do have questions that you let me know. You can email me or you can Zoom with me. So the first question says, and all of these questions, they have said that a person is randomly chosen from the study. So they've picked somebody randomly out of this study. So you can think of it like they've put all of their names in a hat and they're randomly drawing a name. Okay. So if I randomly pick a person from the study, what is the probability that that person would use Snapchat? Well, this is a basic probability problem because it's just saying, what's the likelihood that if I pull somebody randomly that they would use Snapchat? So what we're looking for, if you remember, probability is what you want over the total. So what we want is a person that uses Snapchat. So look at your table and find out how many people use Snapchat. And again, you could add up these numbers in the Snapchat row, or you can look at the totals because they gave you the total here. There was 168 people that use Snapchat, so that's your top number. So there's 168 people out of, well, how many total people were in this survey in all? Well, you can find that one of two ways. You could add up how many people there were kind of that use the different platforms and all, or you could add up the number of people in each age group and you'll end up with the same number. And so they did all that work for you. And so there's 1,310 people that were surveyed or studied and all. So the probability that you get somebody that uses Snapchat, well, you have a 168 out of 1,310 chance of getting somebody that uses Snapchat. Okay. So from there, you can write your answer as a reduced fraction. So if I reduce this, I'd get 84 over 655. Or you can just type it in your calculator and get a decimal from it. So the decimal, if I rounded it 4 numbers past the decimal, I'd get that. And then that as a percentage, which most of the time when people are presenting data, they're going to usually talk about it in terms of percents, especially with this many people. And so they would say, out of my study, I found that 12.82% of the people use Snapchat. That's how they would talk about that number. Okay. So then let's do another one. The second one says, what is the probability that a person is between, or excuse me, that person is between the ages of 13 and 17? Well, this is again a basic probability problem because they're just saying if you randomly choose a person, what's the likelihood that they'd be between 13 and 17? So now we're concentrating on how many people in this study are between 13 and 17. Well, if I look, here's my 13 to 17 people, and in all there are 309 of them. So there's 309 people that are in that age group out of, well, how many people are there total? Well, we just figured that out a minute ago. There's 1,310 people in all. Okay. And again, you could reduce it, or like I said, most of the time when people are presenting data like this, they'll put the percentage. So I'm going to go straight to the percentage. So there'd be 23.59% of people that were studied that were in that age group, in the 13 to 17 age group. Okay, so that's kind of some practice with just some basic probabilities. There are other types of questions that they could ask, and so now we're going to start looking at those. So number 3, and you're going to stop seeing the table after a minute, but I'll make it so you can see it once we get past this problem. It says, what is the probability that person uses Instagram and is between the ages of 18 and 29? So notice this one's adding a little element to it. It's saying, what's the probability that this person that we've randomly chosen uses Instagram and is between the ages of 18 and 29? So you're looking at what's the likelihood that they would be in both of these groups, okay? So you're wanting them to use Instagram and be in this age group. That is an intersection problem, okay? And so remember, with intersection problems, you're looking for the likelihood of both of those things happening. The good thing with these table problems is they actually give you this information in the table. All you have to know is to know what to look for. So if we wrote the notation, which I do want you to get used to seeing the notation, the way that they could write this using the notation would be, what's the probability that this person would have Instagram and be between the 18 to 29, or be in that age group, okay? And so that's the notation. But like I said, with these intersection problems, you can just pull your information directly from the table. You don't really have to do all the work that we had to do before because they're actually going to give you all the information you need, okay? And so I'm going to put that little reminder there so that you can remember that you can get your information straight from the table. So let's look at the table to see where we get our information from, okay? So we're looking for the number of people that are in both of these groups. So, well, here's my Instagram people, that row right there. And then we're looking for those that are in the 18 to 29 age group. So that would be this right here. So there's 67 people that both use Instagram and are in that age group. And so there's 67 people. There's out of, well, how many total people are there? Well, we discussed before, 1,310 people. So we have a 67 out of 1,310 chance that we would get a person that's in both of those groups, all right? And then again, we'll just type it in and get our percentage. So as a decimal, we get 0.0511. And so if we move that 2 to the right, or remember, you can multiply that times 100, you would get 5.11%. So there's 5.11% of these people in this study that used Instagram and were in that age group. Okay. So let me kind of fold this. That way you can see the table and the problem at the same time. Got to get creative here. So number 4 says, what is the probability that he or she uses Facebook and is in the 65 plus age group? It's another intersection problem because they're asking how many people are in the Facebook group and are 65 plus years old. Okay. And so again, you just have to pull out both of your information, or just have to pull your information from the table. So we're looking for the probability that they use Facebook. And so there's the intersection symbol, and are in the 65 plus category. Okay. So look at your table, find how many people are in both categories. So if I look at my table, these are the Facebook people. Look for my 65 plus category. There's 46 people in both. So I have a 46 out of, well, there's 1,310 people in all. So that's the probability as a fraction. And then as a percentage, we get 3.51%. So if I randomly chose a person from this study, I'd have a 3.51% chance that I'd get a person that likes Facebook and is 65 or more years old. So not a very high chance that I'm going to find somebody. And the reason for that is because there's not a very large number of people in that category out of the total. Okay. So number 5, we're switching the questions a little bit. It's number 5 says, what is the probability that they are in the 13 to 17-year-old age group or they use Facebook? So notice this is now an or problem. So if you remember, the or problems are your union problems. And so we're dealing with a union probability problem. Okay. So when we're doing union probability, we can't pull it out exactly like we did here. It's not going to be super simple, super direct. We have to actually do some of the work like what we did in the union probability problems. And so if you remember, union probability is like your addition rule. So just kind of a little review. When you're doing the addition rule, you add the probability of each of these things happening, but then remember, you have to subtract the probability of both of them happening. Okay. And the reason you would do that is if they are not mutually exclusive. In other words, they can happen at the same time. So the thing you have to ask yourself right now is, can somebody that's in this study be in the 13 to 17-year-old age group and use Facebook? And if you look at your table, if I look at the 13 to 17-year-old category in the Facebook, there are people that are in both of those categories. So because of that, these two things are not mutually exclusive, which means there are a certain number of people that are in both. So when that happens, you have to remember to subtract however many are in both. Okay. So the notation is we're finding the probability of somebody being in the 13 to 17-year-old age group, and it's an or problem. So remember the symbol is the U. So being in this age group, or they use Facebook, and I'll just shorten it by putting an F. Okay. So with that, you're going to be finding the likelihood that they're in the 13 to 17-year age group, and then you're going to, and actually let me rewrite this below it so I don't run into my other stuff over there. So you're going to do the probability that they're in the 13 to 17-year age group plus, remember, addition rule, plus the probability that they use Facebook. And then you have to subtract the probability that they're in both. So they're in the 13 to 17 and they use Facebook. All right. So when I do this, well, the percentage or the probability that are in this age group, well, that would be there's 309 in the 13 to 17 year age group out of the 1310. So 309 over 1310 plus the probability that they use Facebook. So we're looking at the Facebook people. There's 323 people in all out of the 1310 that use Facebook. And then we have to subtract those that are in both, because what's happened when we did these two is we've actually counted those that are in both categories twice. And so if you remember, we have to subtract the one that the overlapping part. So there's 51 people, and I got that from here. There's 51 people that are in both categories. So 51 out of the 1310. And then all I have to do is type that in. And notice they all have, and I'm going to zoom in just a little bit so you can see what I'm doing here. And they all have the same denominator. So really, if you type this in your calculator, you could just add these and subtract the 51 and then divide by the 1310. And that would make your life a little bit easier. Okay. And so when you do that, you'll get, there's 581 out of the 1310. And then percentage wise, that ends up being, let's see, 44.35%. So there's 44.35% of these people that are either in the 13 to 17 year age group or they use Facebook. Okay. So the union problems you still have to do kind of like how we did them before, but it is kind of nice because they give you the information. You just have to know how to use it. All right. So let's do number 6. Let me see if I can get it all on there. All right. Number 6 says, what is the probability that person uses YouTube or Snapchat? And it says in the problem, assume these are mutually exclusive. And so there is a reason for that, because if you think about like in real life, a lot of people use multiple social media stuff. And so there's probably some people that use YouTube and Snapchat. So there's probably some people in that kind of like what we did up here that are in that overlapping category that use both. But for the sake of this problem, they're wanting you to assume that they're mutually exclusive, which means, so if I kind of write that out as a Venn diagram, you've got all the people that use YouTube, and then you've got all the people that use Snapchat, and they're saying if they're mutually exclusive that there's nobody that use both. So like that would be what the Venn diagram looks like, is there would not be an overlapping part, okay? Because if they're wanting you to have an overlapping part, consider those people, they'd have to give you more information, okay? So we're going to assume that there's nobody that uses both, and we're going to do this problem. So it says, what's the probability that they use YouTube or Snapchat? Woo, goodness. Cannot talk today. All right. So because there's no overlapping part, we will be doing this problem the same as the other problem because it's an or problem. But because there's no overlapping part, we don't have to subtract anything, okay? Because there would be nothing to subtract if there's nobody that's in either or in the both category, all right? So really for this one, all I have to do is find the probability that they would use YouTube and add it to the probability or the percentage of people. You can think of it about it that way too, the percentage of people that use Snapchat, okay? And so, and again, the symbol for this is the probability that they use YouTube or Snapchat. That's kind of the notation that is the same thing as what this problem's asking, okay? So let's pull our information. What is the probability, or in other words, what's the percentage of people in this study that use YouTube? All right, so if I go up here, it's talking about YouTube in general. So there's 371 people out of the 1310. So 371 people out of the 1,310 people that use YouTube. Plus, let's look at Snapchat. Snapchat, there's 168 people out of the total that use Snapchat. And then that's it, because they told you that there's nobody that used both, or they want you to assume that. And so then you just have to add them. And when you add those two, you get 539 out of 1310. And then if you type that in and get the percentage from that, you end up getting 41.15%. So if there's nobody that uses both, you'd have a 41.15% chance of getting somebody that uses YouTube or Snapchat. Okay, so let me fold my paper again so that you can see the next few problems. All right, the next problem, number 7, says, what if, so I'm switching it up on you here, what if I included that there were 50 people in this study that use both YouTube and Snapchat? What would be the probability that a randomly selected person uses YouTube or Snapchat? So notice it's the same question, but now I've given you that there's 50 people that use both of these things. So the problem will kind of work the same way, except now that you have some people that are in both. So like if you think about it like a Venn diagram, here's your YouTube people, here's your Snapchat people. Now they're telling you that there's 50 people that use both Snapchat and YouTube. So because there is an overlapping part, now we have to actually add in that fact that there's people that are in the overlapping part, okay? And so you still add the probabilities, but remember you have to subtract how many are in both, okay? So that would mean, because there is an overlapping part, and actually I'll draw that over here, because there's people in both, that means that they are not mutually exclusive, okay? There's people that are in both, all right? So because of that, you just have to take the probability of each, and then you subtract the likelihood that you would get somebody that likes both, okay? So you would do probability that they would get YouTube or Snapchat would equal, take the probability that they like YouTube plus the probability they like Snapchat, and then you have to subtract the probability or the percentage of people that use YouTube and Snapchat. Okay, so that's the symbols for it. So we already know this part because we just did that up there. So there's 371 out of the 1310 that use YouTube, plus there's 168 out of the 1310 that use Snapchat. But now we're told that there's 50 people out of the total that use both. Okay, so you just have to subtract that 50. And when I do that, I'm going to write my answer down here, I end up getting 489 out of 1310, which as a percentage is 37.33%. So that's the likelihood that if there were people that use both, which normally there are, that would be the likelihood of getting somebody or that uses YouTube or Snapchat. Okay, so let's do number 8. It says, what is the probability that he or she is in the 13 to 17 or 18 to 29 age group? This is another or problem. So you're going to add the probability of each. And then if there are people that are in both, you subtract that. And so think before you actually write this down, is there anybody that could be both somewhere between 13 and 17 years old? Or excuse me, is there somebody that could be both 13 to 17 years old and 18 to 29 years old? No, you're either going to be in this category or not. So these, luckily, are just mutually exclusive because you can't have anybody that's both or in both age groups. Okay, and so you just have to add the probability of each. So it'd be the probability that they're in the 13 to 17 age group plus the probability that they're in the 18 to 19, or excuse me, 18 to 29 age group. All right. And this is the same type of problem. It's a union problem. All right. So figure it out. What percentage of people are in the 13 to 17 year age group? Well, there's 309 out of the 1310. So 309 out of 1310. plus percentage of people or probability I'd get somebody in the 18 to 29 age group. So that's 371 out of 1310. And then we don't have to subtract anything because they are mutually exclusive. They can't happen at the same time. So from there, we just type it in our calculator. We get 680 over 1310. And then as a percentage, we get 51.91%. All right, so that's a lot of practice with union problems because those are the ones where they kind of work like the other ones. We just have to know how to get our information. All right, so the last type of problem that we're going to do is the problems that we did and worked on the past couple days, which is our conditional probability problems. What happens when they give you information, all right? You just have to know how to read your table, all right? So that's what I'm working with you on here, all right? So in number 9, it says, what is the probability that person uses Pinterest given that they are between the ages of 50 and 64? All right, so the symbol for that is giving you that they are in the 50 to 64 age group, and they're asking you what's the probability that they use Pinterest. All right, so that's what makes it a conditional probability, is because they're giving you some information. So the way to write that is you're finding the probability that they use Pinterest given that they are in the 50 to 64 age group. All right, so that's the notation for conditional probability. And remember, with this, whatever you're given, you're going to think is true. So because they are telling us, they're giving us that they're in the 50 to 64 age group, we are not going to look at anybody except for those that are in this age group. So you only look at the 50 to 64 age group because you kind of act like nobody else exists in all the other age groups just for the simple fact that they told you that this person is in an age group. All right. So when you're finding the likelihood of them using Pinterest, if they're in that age group, your bottom number is going to be how many people are in that age group. So this would be the number in 50 to 64 age group. Well, let's look at our table and find that information. So how many people are in the 50 to 64 age group? Well, if I look at the total, there's 214 total people in that age group. And then on the top, we're looking for the how many out of that use Pinterest. So the number in the 50 to 64 age group that use Pinterest. Okay, so if I look at my table, here's my 50 to 64 year old aged people, and then I'm looking for Pinterest. Well, there's 27 of them that are in that age group. So there's 27 out of that. And so notice it's almost like I've kind of ignored the rest of my table and you only look at what you're given. So that's how the conditional probability problems work, all right? So this was, and I didn't write this down, but I want to make sure that we remember this one was a conditional probability problem, okay? And so from there, you have your fraction. And so as a percentage, we would get 12.62%. So if we knew that the person was 50 to 64 years old, there's a 12.62% chance that they would use Pinterest. Okay, so then let's do one more, and then hopefully this would have been helpful for you. It says, what is the probability that that person uses YouTube? So the probability that they use YouTube given that they are in the 13 to 17-year-old age group. So this is another conditional probability problem. So think about, what are you supposed to be looking at here? You're only supposed to be looking at what you're given. So you only look at those in the 13 to 17-year-old age group. Okay, so in this table, now you're going to ignore everything except for those in this age group. So I'm going to erase where I've circled this one because now we're on a different problem. And now I'm going to circle my 13 to 17-year-old age group. So we're only looking at these guys right here. All right. So that's actually your bottom number in your fraction. So there's 309 people in all in that age group. And out of those people, there are 85 of them that use YouTube. And so that's it. So there's an 85 out of 309 chance that they use YouTube if they are 13 to 17 years old. So that ends up being, as a percentage, 27.51%. All right, let me know if you have questions. Have a wonderful, stupendous, fantastic day.